Today we're going to look at angles of triangles. Notice this is a 2-day topic, so this video could be kind of lengthy just because of how much we are going to be looking at. So previously we learned that the sum of the interior angles of a triangle is 180. So I add up all three angles of a triangle, I'm going to get 180 degrees. If I have a right triangle, then the acute angles are complementary, and that means the two smaller angles are going to add to 90 degrees because with a right triangle, one corner is already 90. So the two smaller angles are going to be adding up to 90 as well. So 90 plus 90 is going to give me 180. Equilateral triangle, each angle is 60 degrees. And then if I have a quadrilateral, meaning a four-sided figure, if I add up all four angles, I'm going to get 360 degrees. So we're going to get right into math, word problems, figures, all that wonderful good stuff. Here we have a vertex of an isosceles triangle exceeds the measure of a base angle by 30. Find the measure of the vertex angle. So we are told we have a triangle, and we're not really worrying about what the angles are and all that. Isosceles means two sides are the same, and we learned the isosceles triangle theorem states if two sides are the same, then the angles are going to be the same. Now the vertex is 30 more than the base angle. We don't know what the base angles are. Since we don't know what they are, we always use x. So the base angle is x. That means this base angle is x. And then this angle is 30 more. So x plus 30. And we know if I add up all three angles, x plus x plus x plus 30, I'm going to get 180. Combine our like terms, we have 3x plus 30, gives me 180. I'll subtract 30 from both sides. So we end up with 3x gives me 150. And when we divide by 3, we get x equals 50. Now we needed the vertex. So x being the base angle, the vertex was x plus 30. So 50 plus 30 gives me an angle measurement of 80 degrees. Second problem, we are told to state what kind of triangle we got if angle A is 9x, angle B is 3x minus 6, and angle C is 11x plus 2. So again, we have a triangle. We don't know what it is. We're just going to put an angle. We know one angle is 9x. We know another angle is 3x minus 6. And our third angle is 11x plus 2. And just like before, if I add up all three angles, 9x plus 3x minus 6 plus 11x plus 2, I'm going to get 180. I'm going to combine my like terms. 9, 3, and 11x gives me 23x. When I add negative 6 plus 2, I get minus 4. Gives me 180. If I add 4 to both sides, I have 23x is 184. And then I have to divide by 23, which means x is 8. So 23 times 8 is 184. So we got x equals 8. So now we need to figure out how much each angle is worth. So we know angle A is 9x. So in this case, it's 9 times 8, which is 72 degrees. We know angle B is 3x minus 6. So 3 times 8 minus 6. So 24 minus 6 gives me 18 degrees. And last but not least, we have angle C, which is 11x plus 2. So 11 times 8 plus 2, which means we have 88 plus 2, giving us a 90-degree angle. So we have 90-degree angle, 72-degree angle, 18-degree angle. So 90-degree angle means we have a right triangle. based on the angle measurement. And if I were to apply it to our sides, the angle measurement also helps us out. Since all three angle measurements are different, that will mean all three sides are different as well. So again, we had equilateral where all three sides are the same. We have isosceles where two sides are the same, and scalene is when none are the same, when all three are different. So all three angles are different. That means all three sides are different. So we have a scalene triangle based on that as well. Now sometimes what happens is you'll get a triangle with a side extended out a little bit, and it's what we can use here is known as the exterior angle theorem. What that says, the exterior angle is equal to the sum of its two remote interior. So if I were to label these 1, 2, 3 in the triangle, and then 4 is the outside. Again, exterior means outside. So angle 4 being the exterior angle, I need to set it equal to the two remote interior. So I need two angles that are inside that are not attached to angle 4. So angle 3 is right next to angle 4. That is not a remote interior angle. Angles 1 and 2 being farther away, those are the remote. So angle 1 plus angle 2 will be the example. And we can actually prove this theorem. So if I take the same triangle up here, we know that if I add up the three angles of a triangle, angle 1 plus angle 2 plus angle 3, I'm going to get 180 degrees. Based on the fact that I have an extended line over here, I know if I add the two angles here, that angle 3 plus angle 4 is also going to give me 180. So whenever I have two equations like this where they both equal the same thing, so 1 plus 2 plus 3 gives me 180, and 3 plus 4 also gives me 180, I can actually cut out the middleman, the 180, and set my two adding parts of the equation equal to each other. So I can say angle 1 plus angle 2 plus angle 3 is equal to angle 3 plus angle 4. And again, it's because when I add these guys up, I get 180. When I add these two up, I get 180. So because they equal the same thing, the two adding parts are also the same. So notice here that on both cases, I have angle 3 on both sides. So I can actually subtract angle 3 because it's kind of redundant. We don't need it. And what's left is angle 1 plus angle 2 equals angle 4. So this is the remote exterior angle theorem. When I have the two far angles inside a triangle equal to the outside angle of the extended piece. So for example, we got a bunch of examples here that we can use. So we have angle measurements of x squared, x minus 12, and 5x. These are far away from 5x, so we can say 5x equals x squared plus x minus 12. I'll subtract 5x because now I have x everywhere on one side, so subtract 5x. So we get 0 equals x squared minus 4x minus 12. Here I'm going to try and factor. Again, factor means I set this up where I have two sets of parentheses. The first guy in our parentheses will multiply to be x squared. So x times x is the only way. And for 12 and 4, my numbers that I pick will have to multiply to negative 12 but add to negative 4. So if I think about factors of 12, we got 12 and 1, 6 times 2, 4 times 3, and that would be it. So I need, with the pair, that I can somehow, some way get negative 4. And the only one that would work would be the 6 and the 2. So my numbers are 6 and 2. Now multiplication, I get a negative, and the only way that I can get a negative is a positive times a negative. Question becomes which number is going to get the negative, which one gets the positive. Well, the rule of thumb is whatever my middle term has, the larger number will get. So middle term is minus 4. So my larger number will get the minus, in this case it's going to be minus 6 plus 2. And now I split these up and set each one equal to 0. So 0 equals x minus 6 and 0 equals x plus 2. I'll add 6 to both sides, and I get 6 equals x. Over here, I'll subtract 2 to get negative 2 equals x. So in this case, we have two different values of x that would work. 6. So if we plug in 6, we can get 6 times 5 would be 30. 6 minus 12 is negative 6. And x squared would be 36. So 36 minus 6 is 30. That works. And if I did the same with the negative 2, 5 times negative 2 is going to give me negative 10. So negative 2 minus 12, negative 14. Negative 2 squared is positive 4. So 4 minus 14 gives me negative 10, and that works as well. So I actually have two different values of x on this particular one, 6 and negative 2. Number 2 here, we have to find A and B to justify our answer. So here's angle B, here's 93 degrees on the outside over here, 69A, 58. Notice here we have a small triangle with 2 out of the 3 angles. And we know that, again, a triangle, all 3 angles add up to 180. So 69 plus 58 plus A gives me 93. If I add 69 and 58, I will get 127 plus A. Not 93, it's 180. That should be 180. 180. I'll subtract 127. And I get 53. So now we know that angle A is 53 degrees. So 93 is being on the outside, so it follows that. So I want the triangle that, and again, I always follow the 2 lines. So 93 comes down here, then it goes off. So I'm looking at the large triangle. So 93, we know 93 being on the outside, it's going to be equal to the sum of the 2 far angles. So the far angles in this case would be B and 53. So we can say 53 plus B gives me 93. And all I have to do is subtract 53 from both sides. And I get a B value of 40. So A is 53, B is 40 using the exterior angle theorem. And now we get to figure out the missing angles here. So 3, 4, and there's a whole bunch of these problems. So 3, the first few are relatively easy looking, very basic figures. So 3, 42A, 78, we'll just use the theorem. 42 and A being the far angles, we add them together, and I get that outside angle measure. So all I have to do is subtract the 42. So I get A equals 36. B, we have this diagram here, or number 4, we have the diagram here, angle measurement of 68 up here, and angle measurement to be on the outside. Got a little 2 marks here on the side say that we got an isosceles triangle. Theorem states the angles across are equal as well. So 68 being across from this slash, I go follow this slash over here. So this is also 68. Same deal as above. Outside angle is equal to adding the 2 far angles. So 68 plus 68 is going to be B. And we get 136 degrees for B. 5, we start breaking things up a little bit. We have a right triangle. The largest triangle is a right triangle. We are told this part in here is D. We have an angle measurement of 64. 95, and angle measurement of C. So we can figure out each one however we want. So C on the part of the big triangle, we have angle measurements of 90, 64, and C. So if I add them up, we learned if I have a right triangle, the two acute angles add up to 90. So C plus 64 is 90. Subtract 64. And I get an angle measurement of 26 for C. Now to figure out D, D is part of this small triangle here. And we have the exterior angle of 95. So D and 64 being on the far side from 95. So 95 is equal to D plus 64. We subtract 64. We get angle measurement of 31 degrees. Number 6, we start getting even fancier. We got a whole bunch of stuff going on here. We got angle measurement of E, 34, 30, and 115. So we have to just kind of go along and try and figure things out. So 115, we know this outside angle is also 115 because they're vertical angles. Whenever I cross two lines, angles across are equal to each other. And what we have here, again, is a solid line. So what we have to do is 180 minus 115 to get these two angles here. And that means we have angle measurements of 65 degrees. So these two angles, 65, 65. So for this small triangle down here, we have 30 and 65. 30 plus 65 plus our unknown down here in the bottom corner. We'll label it as X, gives me 180. 95 plus X is 180. We'll subtract 95, and we get 85 degrees for this one. And we just learned that 85 plus 95 is 180. So if this angle is 85, that means this angle is 95 since it makes a straight line. And then up here we have another triangle, two angle measurements, 65 plus 34 plus another unknown. This time we'll use Y, gives me 180. 65 and 34 is 99. Plus Y gives me 180. We'll subtract 99. So Y is 81. So 81 for this one, and then that means this angle here is 99 since we have a straight line. Again, two angles here will add up to 180, 99, 81. So finally we're down to this four-sided figure. Again, four-sided figure is nothing more than a quadrilateral. And we've just learned that a quadrilateral, all three angles add up to 360. So I have angle measurements of 99, 115, 95, and E. And I will get 360. So what I want to do is I want to add up my like terms here, 99, 115, 95. So when we do that, we have, let's see, 210 and 309 gives me 360. 309 E plus 309. We'll subtract 309. And I get E is equal to 51 degrees. So a lot of work to get there in the end, but we do get to the point where we are able to state what E is equal to. 7, we have angle measurements of 94, 57, and G. We have the markings on the two diagonal lines stating that they are parallel to each other. So we can say that we have two parallel lines cut by a transversal. So now in order to figure out what they are, again, G being on the outside, we know that this angle up here is going to be, so parallel line cut by transversal, this angle is going to be 57. And now all I have to do is figure out what these angles are as well. So what I can do is draw a auxiliary line through here that I can say is parallel to my other two angles. So parallel line cut by a transversal. This tells me this full angle here is 94 degrees. And then this angle here is 57 degrees. So here we have vertical angles. So my parallel line to the outside, so parallel line to the outside. This tells me this section right here is also 57 degrees. So what I need to do now is figure out what this portion is over here. So if I know the whole thing is 94 degrees, well, 94 minus 57 will give me this purple section. When I do that, I will get 37 degrees. So again, vertical angle. So now that we know that this is 37 and that's 57, we know we have 94-degree angle. So parallel lines cut by transversal. So here 94, 94. This is also 94 degrees. And fortunately for us, we can now split this up as x and x. If I go the full way around, I'm going to get 360. So we really have 2x plus 188, giving me 360. I'm going to subtract 188. And I get 172. Divide by 2, 86 degrees. So G being 57 and 86, and I get 143 degrees equals G. So that was kind of convoluted, a little long, but we get there in the end. Now number 8. We have 72, 30, 25 degree angles, and H being on the outside, we need to figure out what H is. So how are we going to do that? Well, we can do it a couple different ways. We can either extend out this way, so we make a nice triangle, and go that way to make a triangle over here. So if this is 25, that's 72. We know a triangle adds up to 180. So 72 plus 25 plus x is 180. We get 97 plus x, 180. And we'll subtract 97. So x is going to be 83. So this angle over here is 83 degrees. And the other triangle would be 72 plus 30 plus y in that corner, going to give me 180. So we get 102 plus y gives me 180. When we subtract 102, we get 78. So what we really have here is missing angle here and h. So if I think about it, I have two lines. I end up with vertical angle. So if this is h, I can say this angle is h as well. So here we have a four-sided figure that if I add up all three angles, I'm going to get 360. So 72 plus 83 plus 78 plus h equals 180. So I'm going to add up my three angles, 72, 83, and 78. 72 and 83 is 155 plus 78 plus h is 180, or 360, my bad, 360, not 180. And then when I add 55 and 78, 220, 233 plus h gives me 360. I subtract 233, and we get h equals 127 degrees. So again, long road, but we get there and figure things out. Here we have angle measurements of 5x minus 3, 4x minus 2, j, and 10x minus 20. In this case, we're going to use the exterior angle theorem, where the outside is equal to the two remote inside. So 5x minus 3 plus 4x minus 2 is equal to 10x minus 20. I'll combine my like terms over here. So 9x minus 5 equals 10x minus 20. It's always easier to move the smaller variable over, so minus 9x. So we get negative 5 equals x minus 20. Add 20 to both sides, so we get 15 equals x. So now that I know what x is, I can do it one of two ways. I can plug it in to get the two angles and then add j to it to get 180, or I can use this angle plus j to get 180. In the end, it's going to be the same thing. In this case, I'm only dealing with a couple angles, not all three. So I would tend to use this. And we know that j plus 10x minus 20 is equal to 180. So j plus 10 times 15 minus 20 is 180. 10 times 15 is 150. So we got j plus 150 minus 20 is 180. Combine our numbers, so we get j plus 130 is 180. Subtract 130, and we get 50 degrees. That one was relatively simple. Now 10, we have these lines, then a dip, and then another line. The arrows represent the fact that they are parallel, so I can actually extend this line out. So these lines are parallel to each other. We have this transversal here that cuts. So if this is 125, this tells me this angle right here is 125. So if this is 125, we know it's a straight line. They're going to add to 180. So 125 plus x is going to give me 180. Subtract 125 from both sides. we get x equals 55. And now, fortunately for us, we have an exterior angle of 150 and then two remote interior. So we can say that 55 plus I equals 115. And all we have to do is subtract 55 to get I equals 60. So that one was pretty simple as well. Again, parallel lines cut by transversal, we have alternate interior angles. And then we know a straight line adds to 180 degrees, which means we can figure out this angle here is 55. And then the exterior angle theorem, add the two far angles inside and say equal to that outside. Now number 11, we have a whole bunch of markings going on. We have angle measurement of 56 and K. We are told that the larger triangle, the two sides are the same, and then the smaller triangle, we got two sides the same as well. So based on this, we know up here being 56, we know that this angle and this angle are the same. And we know that if I follow this side, again, it's only dealing with the smaller triangle, so this angle and that angle are the same. So the full way around is going to be the equal angles. Now, because we don't know what these angles are, we can label them x. So if this angle is x, this angle is x, and then the full angle over here is x. Now we know that the angles of a triangle add up to 180. So we can say x plus 56 is 180. So we got 2x plus 56 is 180. When we subtract the 56, two x is equal to 140 or 134 or 124 actually, 124. Divide by 2, and we get x equals 62. So let me erase these and put in the markings that we do know. So this is 62. This is 62. And then this whole thing is 62 degrees. So now we have to figure out what K is equal to. Now, fortunately, it's the same thing that we just learned. So the angles of a triangle add up to 180. So 62 plus 62 plus K is 180. Now, fortunately for us, we just pretty much had the same equation. So in this case, we end up with 124 plus K is 180. Subtract 124 and we get K equals 56. So this one was kind of quick and easy, kind of odd, but it works. 12. 12 again, we got a set of parallel lines. This time they're diagonal. We have a right triangle, or we have a right angle measurement of A, 95-degree angle, and a 39-degree angle. We have to figure out what A is equal to. So, how are we going to do that? Well, if I have parallel lines cut by transversal, I know this angle is going to be 39 degrees because it is alternate interior angles. And we know that a straight line is equal to 180. So if I want to find this angle right here, I just have to add up my three angles, 95 plus 39. And since we don't know what it is, we'll call it x. It's going to be 180. When I add up 95 and 39, I get 134. plus x is 180. Subtract the 134. And I get x equals 46. So this angle here is 46 degrees. And now we have a right triangle. And again, we learned that if I have a right triangle, the two acute angles will add to 90 degrees. So 46 plus a is 90. Subtract 46. A equals 44 degrees. We got a large triangle, we got a smaller triangle, we have to figure out what angle B is, and we have a 58-degree angle in here. Here we have parallel line cut by a transversal, and isosceles triangle. So this one's actually pretty quick and easy. So again, parallel lines cut by a transversal. So if I look at 58 and I look at B, they are on opposite sides of the transversal on the inside. So they're alternate interior angles. So this one's relatively easy. 58 equals B, alternate interior angles. And then last but not least, 14, we're given 2x plus 9, 3x minus 1, c, x plus 12, 42-degree angles, and we have markings on two sides here that show we have isosceles triangle, and we can maybe use that to our advantage. So where to begin? Well, let's start with the isosceles triangle. So we know that if I have an isosceles triangle, the angles across from the congruent sides are also congruent. So if I follow this, we have a 42-degree angle in this corner, which means this corner is also 42 degrees. Now what we want to do is we can actually sort of figure this out. So if this is 42, 42, I can figure out this large angle here. 42 plus x is 180. So we get 84 plus x, 180. Subtract 84 from both sides. And we get x equals 96. So this angle is 96 degrees. Now, in order to figure out what c is equal to, we might have to use we are going to use the exterior angle theorem. So this angle here, the outside, so again, so if I take a look at the exterior angle here, I'm going to follow the line. So I follow this line here, all the way over to here, and I see I encompass this triangle here. So the exterior angle is our 96 plus the x plus 12, and that is equal to the two far angles, 2x plus 9 plus 3x minus 1. Now I'm going to combine the like terms on both sides. So 96 plus 12 means we have 108 plus x is equal to, and then on this side we got 5x plus 8. I'll subtract the x since that's a smaller one, so we have 108 equals 4x plus 8. If we subtract 8, we get 100 equals 4x, and we have to divide by 4 to get 25 equals x. So again, we can do this one of two ways. We know that if I add up the three angles along this line here, I'm going to get 180. And I know if I add up the three angles inside my triangle, I will also get 180. In this case, it really doesn't matter which one we use. because you're still going to be doing a whole bunch. If I just add up the three angles to get 180 for the line, it'd be a little bit easier because there's only one substitution. So we have x plus 12 plus 96 plus c is going to give me 180. Well, x is 25. So I end up with 25 plus 12 plus 96 plus c gives me 180. I'm going to combine my like terms. So 37 and 96 is 133. Plus c gives me 180. I want to subtract 133. And we get c equals 47 degrees. And again, this is using the exterior angle theorem, triangle sum theorem, isosceles triangle theorem, pretty much everything we've learned about triangles and their angle measurements, along with relationships that we use when dealing with parallel lines cut by transversal in order to find missing angles. So yes, sometimes there's a lot going on in the picture, but take it one thing at a time, plug in what you know, and then take a look and see what relationship we're dealing with in terms of angles, parallel lines, and triangles.